A wire of length L is traced to double its length. Compare the resistances of the original and traced wire. Suppose length of the original wire is equal to L and length of the traced wire is given double the length of the original wire. So length of the traced wire is equal to 2L. Suppose the area of the original wire is A and area of the traced wire is equal to A dash. We know in the process of stretching, volume remains constant. You have to remember this, the physics of stretching, that in the process of stretching, what remains constant? The volume remains constant. So volume of the original wire must be equal to the volume of the stretched wire, because in stretching process volume remains constant. So if you compare the volume of the two wires, that is original wire and the stretched wire, then volume of original wire will be equal to volume of the stretched wire, because we know the volume is given by the formula area into length. Wire is in the form of a cylinder, so the volume of the cylinder will be equal to area into length. So volume of the original wire is equal to area into length, and volume of stretched wire is equal to A dash into length. You see, the area will vary. Here the area is A and here the area is A dash. The area will vary, but the volume remains constant. So here you can compare the volume, that is A dash will be equal to A divided by 2. We know resistance of a wire is given by the formula R is equal to rho into L by A. So what will be the resistance of original wire? That is equal to R is equal to rho into L by A, and resistance of stretched wire suppose is equal to R dash, that will be equal to rho into 2L by A dash, because here the length is L and in stretched wire the length is 2L, and area in original wire is A and in stretched wire it is A dash, but resistivity is rho, and for the same material the resistivity in both the case will remain same. So if you write A dash, as you have found out A dash is equal to A by 2, so if you write or substitute here A dash is equal to A by 2, then R dash will be equal to rho into 2L divided by A divided by 2. So this will be equal to rho into 4L divided by A. That means 4 into rho L by A. And we know rho into L by A is equal to R. So R dash will be equal to 4R. So if you find out the comparison between the two wires, that is the original wire and the stretched wire, then R dash divided by R will be equal to 4R divided by R, that will be equal to 4. So if a wire of length L is stretched to double its length, then the ratio of the resistance of stretched wire to the resistance of original wire will be equal to 4.